Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today, I'm going to be going over how to balance equations, so if you have any questions, make sure you let me know in class. Let's talk about the law of conservation of matter. So the law of conservation of matter is something we talked about in the first semester, and it's something that we've kind of talked about already in the second semester. So remember that mass or matter is neither created nor destroyed in a chemical reaction. It just rearranges itself, and so it is preserved in some way, shape, or form. So what that means is that if you have a chemical reaction like this, I have hydrogens, I have oxygens, and I'm reacting them together to make waters. That means that you must always start and end with the same amount of materials. So that means I have to count. So if I'm counting how many blue circles I have 4 on this side, I have 4 on that side of the arrow. How many oxygens? They're red. I have 2 oxygens on this side. I have 2 oxygens on that side. Therefore, the law of conservation is being followed. If for some reason these were not the same, like, let's say I only had, I don't know, a 1 hydrogen here. So I had these 2, but I didn't have these 2. It wouldn't add up. I'd have too few hydrogens on this side, and I'd have too many hydrogens on that side. And that's not how the law of conservation works. So by putting a 2 here and having double, and having a 2 here and having double, I am balancing this equation. Again, picture this if there weren't any coefficients in front of this and no coefficients in front of this. If I had 2 of these, and if I had these 2, and I had these 2, and I had this right here that I was making, I would not have enough oxygens on this side because I'd have, 1 leftover oxygen, and I don't have a leftover oxygen here. So balancing equations is extremely important in following the law of conservation of matter. So how do we balance an equation? Well, you just kind of saw. We put coefficients in front of the chemical formula. So what is a coefficient? It's a number that you put in front of something to multiply by it. So you're used to seeing this in math. 2x squared plus 3x minus 4 equals 0. These right here are coefficients. What this is telling me is I don't just have x squared, I multiply 2 times x squared. What this is telling me is I don't just have x, I'm multiplying 3 by x. But in chemistry, it's exactly the same. These right here are your coefficients. So instead of just 1 H2, I have double. I have 2 H2s. Instead of 1 H2O, I have 2 H2Os. And so that's how coefficients are used in chemistry. But the principle is the same. Now here's a little side note. You never, ever, ever, ever change the subscripts. So for example, like I said, this is allowed. You can put 2s in front of anything. You can put 3s, 4s, 5s, as long as they're whole numbers, you can put them in front of any one of the chemicals in your chemical equation. Now, what's not allowed is, oh, hey, I have a 2 here and I have a 2 here. I'm just going to carry that through and multiply everything through. And so instead of 2 H2s, I have H4. Instead of 2 H2Os, I have H4O2. That's not allowed. That is forbidden. And the reason why is pretty simple. A lot of times when you do something like that, these formulas don't exist. H4 is not something you ever would find in nature. It doesn't exist. H4O2 also doesn't exist. So if you think, oh, hey, I can simplify this by multiplying this through by 2 and multiplying this through by 2, you're actually creating something that isn't real and doesn't exist in nature, and so that's not allowed. Now, what do we call the relationship between the coefficients? That's called a mole ratio. So for example, right, I have 2 H2s, I have 1 oxygen, and I'm making 2 water molecules. That's what we call our mole ratio. So it's kind of like a recipe. I think of it like the ingredients for something, right? So if you wanted to know how many, how much carrots, how many carrots, I guess, how many tomatoes and how many cucumbers to put in a salad or something, and I said, 2, 3, 2, if you knew the order, which you do because the chemical equation is, in order here, you could very simply say, okay, that's 2 carrots, that's this many tomatoes, that's this many, cucumbers or whatever. That's what the mole ratio is. It's like a shortcut recipe here. So instead of saying 2 hydrogen molecules, 1 oxygen molecule, 2 water molecules, you can say 2, 1, 2. That's it. And what does this mean? 2 hydrogens, 1 oxygen, 2 waters. It's like a shortcut. Okay, what are our rules? First thing, always make sure your formulas are correct and always make sure your arrow is in the proper spot. Okay? Next, count the number of elements you have in your reactants and in your products. And remember, you can always count polyatomic ions as a unit if it helps you. Okay? We'll talk about that in a bit. Then what do you do after you've counted everything? Then you can start adding your coefficients. So add your coefficients to one thing that appears on both sides of the equation in order to balance it. Remember, when you're done doing that multiple times, make sure your mole ratio is in the smallest whole number possible. And then check your work to make sure that your formulas and your elements are still the same on both sides. So in other words, make sure you didn't try to change something by accident, oh, I changed my subscript by accident when I was writing something down. Okay, let's actually do this then. Write the balanced chemical equation for nitrogen gas reacting with oxygen gas to make dinitrogen tetroxide. All right, so I've got nitrogen gas plus oxygen gas making dinitrogen tetroxide. All right, let's count. How many nitrogens do I have on this side? How many nitrogens do I have on that side? How many oxygens do I have on this side? How many oxygens do I have on that side? So I'm counting. I have 2 nitrogens on this side. I have 2 oxygens. On this side, I have 2 nitrogens. I have 4 oxygens. Okay, the nitrogens are balanced, but the oxygens aren't. That means I need to put a number in front of the oxygen carrying molecule on this side in order to balance them. What number can I put in front of this in order to make this 4? 2. When I do that, now I have 2 nitrogens, I have 4 oxygens, everything is balanced. I'm already done. What is the mole ratio for this equation? It's a 1 to 2 to 1. Simple as that. Of course, this is like the simplest example, but still. Next up, let's write the balanced equation for aluminum bromide reacting with potassium sulfate to make potassium bromide and aluminum sulfate. All right, aluminum bromide plus potassium sulfate makes potassium bromide and aluminum sulfate. All right, let's count. How many aluminums, bromines, potassiums, and this is a polyatomic ion, sulfate. I can keep SO4 together. Notice SO4 appears on both sides, so I can keep it together. Okay, I have 1, I have 3, I have 2, and I have 1. What about on this side? I have 2, I have 1, I have 1, and I have 3. All right, pick something to balance. It doesn't matter what you pick. All right, what if I put a 2 here? If I put a 2 here, now I have 2 aluminums, which is good. And now how many bromines do I have? I have 6. Okay? So great, I balanced my aluminums, but now I have 6 bromine and I only have 1 bromine. So how can I balance that? Okay, well, if I put a 6 here, now I have 6 bromine, and now I have 6 potassium. But I only have 2 potassium here, so I'd have to put a 3 in front of this to make that 6. And now look, I have 3 sulfates, I have 3 sulfates. So now if I count, I actually have balanced my equation. Notice what I did though. I just picked one thing to balance. Once I balanced that, that changed something. And now I have something else to balance. And then, oh, look, now I have something else I can balance. And you keep going back and forth until you have, your balanced equation. And that's how you balance any chemical equation. Okay? What is the mole ratio? What's my recipe? It's a 2 to 3 to 6 to 1. And again, that's the way you would write it, 2, 3, 6, 1. Last example. Let's balance this. Okay, so I've got two carbons, 4 hydrogens, and 2 oxygens on this side. I've got 1 carbon, 2 oxygens. Oh, wait, no, 3 oxygens. No, look, I've got 2 here. I've got 1 there. That's 3 oxygens. And I've got 2 here for my hydrogens. So pick something to balance. What's the easiest thing to balance here? Put a 2 in front of this. But look what that does. That now changes the number of oxygens that I have. So look, what do I have now? I have 5 oxygens, and I only have 2. Okay, what's something else I can balance? Put a 2 in front of this. Now I have 4. So look, I balanced my carbons and I balanced my hydrogens. Now let's look at my oxygen. So I have 2 times 2, so that's 4, plus 2, that's 6. I have 6 oxygens on this side now. I only have 2 on this side. What number could I put in front of this in order to change this to 6? I could put a 3. What's well, now look, it's all balanced. What's my mole ratio? 1, 3, 2, 2. All right, that's it. So if you have any questions, let me know.